Static electricity is always present in your process, and the potential of static electricity buildup to spark explosions, costly fires, property damage and injury to operators is a constant danger. The consequences of this invisible hazard have been seen many times. Yet the static electricity experienced in our daily lives appears to be relatively harmless, if a little unexpected. So what can turn a familiar phenomenon into a serious hazard facing the process industry? Certain conditions need to be met before an electrostatic discharge can cause ignition. The mixture of the solvent vapor and air must be within its explosive range and be present. There must be means of generating the electrostatic charge, and the charge must accumulate to a level with enough energy to initiate an igniting spark. Normally, the spark jumps across a spark gap, but other discharges can occur, such as brush discharges from a charged surface, such as plastic. The risk due to this hazard can be minimized by limiting the accumulation of electrostatic charges to safe values, by controlling the rate of generation, and by providing the means of dissipation, or by eliminating the presence of a flammable vapor-air mixture. This film will deal with the sources of static electricity, good operating practice to minimize charge buildup, effective earthing and bonding, its installation use and testing, and the technical support, codes of practice, and legislation available. SIA and ESIG are providing this overview of the hazards of static electricity and the mitigating measures available to increase awareness among solvent users. Static electricity can be generated in the solvent or on non-conductive surfaces such as plastic drums. Static electricity charge can be generated in solvents by liquid movement such as flow, mixing, pouring, pumping, filtering, or agitation operations, where the movement separates electrical charges which may accumulate in the liquid and the containment system, such as pipes, tanks, drums, road tankers, rail cars, and ships. If either of the materials is a good insulator, or the plant is isolated from earth, electrostatic charge will accumulate. A good example is liquid flowing through a pipe. Negatively charged electrons move across the boundary between the two bodies and are then unable to return. The charge on the containment system can be dissipated quickly by earthing, but the charge in the liquid remains and is slowly dissipated, depending on the conductivity of the liquid. How quickly the static electricity charge builds up depends on a number of factors. Turbulence of the liquid, the speed and contact of the liquid with its surface area of its surrounding equipment, the presence of impurities, and how quickly the earthing equipment can remove the charge. The amount of charge remaining after a given time depends on the amount generated and the amount dissipated. The time required to ensure the charge dissipates to a safe level is known as the charge relaxation time, which will vary with different solvents. Turbulence experienced in filling operations, caused by large flow rates, splashing, or free-falling liquids, greatly increases the charge accumulation beyond the level generated in pipes. Filters, because of their large surface area, can generate as much as 5,000 times the electrostatic charge generated in a pipe system without filtration. Dispersing operations can be particularly hazardous in view of the extremely high rate of charge generation when particulates are present. High charge rates can also occur when liquids containing non-miscible components are mixed or agitated. With poor conductive liquids, the charge accumulation can cause sparking in the vapor space to an exposed agitator blade in a mixer or to a filling pipe. The electrostatic charge built up in the liquid will dissipate by migrating from the liquid to an earthing point. The rate of dissipation depends on how readily the liquid will conduct electricity. Hydrocarbon solvents have low conductivities and do not readily conduct electricity. The slower the rate of charge generation, the more chance it has to dissipate and avoid reaching the level of charge sufficient to cause an igniting spark. The generation of static electricity cannot be eliminated, but its rate of accumulation should be minimized. although this is not always possible for some end uses of solvents, such as spray applications. In pipes, there are recommended safe maximum velocities for hydrocarbon solvents for various pipe diameters, but there are exceptions for particular solvents and for the presence of contaminants. During filling operations of tanks, road tankers, rail cars, ships, IBCs, drums and cans, splash filling and free fall of flammable liquids should be eliminated to the maximum extent practical by providing diverters to discharge the liquid down the side of the earthed container, or by submerging the fill pipe below the liquid level to the bottom of the vessel. Incoming velocity should be reduced until the pipe is below the surface of the liquid. It is particularly important that the velocity of the incoming liquid or liquid being discharged is controlled, so operations such as gravity filling of IBCs from road vehicles should be avoided. Once a filling operation has been completed or a vessel has been mixed, it may be necessary to dip or sample, and a sufficient time should be allowed for the accumulated electrostatic charge to dissipate. The charge relaxation time. Storage tanks can contain a small amount of second phase, for example water, and the relaxation time should be considerably longer than for the pure solvent. Care must be taken when the receiving tank, compartment or container has not been cleaned out and contains flammable vapor, particularly when the next liquid has low conductivity. Experience has shown that installing filters far enough upstream of discharge points to provide a sufficient liquid residence time greater than the specified charge relaxation time of the liquid will avoid problems. This can also be achieved by the installation of a relaxation chamber. For dispersing operations, the conductivity of the liquid should be raised before particulates are added. If possible, conductive solvents should be added first. In some cases, proprietary anti-static agents can be added to reduce the charge accumulation. Typically, only a few parts per million are required. However, these additives can cause problems with formulation and can separate out during bulk transfer operations. Where it is not possible to reduce the buildup of electrostatic charge to a safe level, inert gas blanketing should be considered both for vessels and pipes. Earthing and bonding is a very effective technique for minimizing the likelihood of an ignition from static electricity, and is particularly important where the end user of solvents cannot avoid the generation of static electricity due to the nature of the process, such as a spray application. Earthing establishes a continuous electrical path to earth and will remove charge rapidly. Conductive equipment is connected to an earthing electrode or to the building earthing system in order to prevent sparking between conductive equipment and earthed structures. A bonding system connects various pieces of conducting equipment together to keep them at the same potential. Static sparking cannot take place between objects that are at the same potential. In potentially flammable locations, all conductive objects electrically isolated from earth by non-conductors, such as non-conducting pipe or hoses, flexible connections, equipment supports, gaskets, should be bonded. Bonding straps and cables and earthing bars should be durable and low resistance, of less than 10 ohms. Portable equipment must be earthed back to the process equipment or common earthing system, using the appropriate flexible cables and clamp. The clamp must make contact with metal surfaces through paint, rust, and surface contaminants. Drums and cans must be earthed back to the loading system via earth leads and a special earthing clamp that penetrates the paint coating. Preferably, the earthing clamp is in a separate location to the source of the flammable atmosphere. When decanting from one drum or can to another, ensure the receiving vessel is earthed and the source vessel is bonded to the receiving vessel. When using metal IBCs, the frame around the tank may not be bonded to the tank via an earthing strap, and therefore both frame and tank need to be earthed separately back to the loading system. Generally, it is recommended that plastic IBCs and drums should not be used for low-flash solvents, as the plastic surfaces themselves can become charged by brushing against them, and any charge buildup in the solvent cannot be removed. Some plastic containers have a special provision for earthing, and the operator must be satisfied that it is robust and reliable, earth-proofing equipment is available, and that any potential for brush discharge from the surface is eliminated. Earth-proofing systems offer a continuous confirmation of earthing and can prevent and halt operations if there is an earth failure. When filling road tankers, special earthing conditions must be made, as the resistance to earth of a vehicle can exceed the recommended maximum resistance. In all instances, the earthing clamp should be attached to the vehicle before any other operation, and should not be removed until all operations are complete and there is no presence of vapor. For situations where permanently interlocked filling systems are not provided and the use of portable equipment is required, for example mobile pumps, this equipment must be earthed back to the process equipment or common earthing system using the appropriate flexible cables and clamp. The clamp must make contact with metal surfaces through paint, rust, and surface contaminants. When discharging, the source vessel should be electrically connected to the receiving vessel. If temporary storage is used, an assessment of earthing provision and associated earth testing should be carried out. The equipment for dipping or sampling should be of conductive material throughout and bonded to the tank, or of natural fiber. Dipping or sampling should only take place after the appropriate relaxation time has elapsed. If flammable liquids are handled, static dissipative footwear should be worn and tested on a regular basis by all people present. The proper installation and effective inspection and maintenance of earthing and bonding systems and devices are important in the protection of personnel and equipment. To ensure a high level of static electricity awareness is maintained, there should be regular testing of equipment with results logged, frequent awareness training of operators, and reference to the appropriate standards. The fixed part of the earthing system, the earthing rods, the earthing loop, bonding on fixed equipment should be tested periodically, usually by a specialist, often in conjunction with tests on lightning protection equipment. A typical test period would be 11 or 13 months, testing during different seasons, and would look for any significant variation from previous tests, indicating deterioration. Earth-proofing systems are normally tested every 12 months. Earth leads and clamps for portable equipment should be tested more frequently, every 3 months, using an intrinsically safe earth lead tester. It is essential that operators using flammable solvents are aware of the hazard of static electricity. Safety data sheets will indicate if flammable vapor air mixtures will be present during handling of the solvent, and if so, it should be assumed that static electricity could be a problem. Even for oxygenated solvents that have better conductivity, but can accumulate a hazardous high level of charge, such as acetates. This can be confirmed by contacting the supplier for further technical support. There should be reference to the various European and international standards when installing and maintaining a static electricity protection system. References will be found in many different standards, whether they be specifically for static electricity, or for handling flammable liquids, or operating in hazardous atmospheres. It is recommended that you consult your local health and safety regulators and specialists for further advice. Over the course of this DVD, we have seen how a familiar phenomenon can be a serious hazard. Certain conditions can cause an ignition, the presence of a flammable mixture, and the generation of static electricity to a spark ignition level, either within the solvent or on plastic surfaces. We have shown how this hazard can be eliminated through good operating practice and use of tried and tested earthing and bonding equipment. Solvents have a vital part to play in industry and in many ways enable us to have the products and resources that are fundamental to our daily lives. Some solvents are hazardous, and this film has highlighted the particular hazard of static electricity. The solvents industry is well regulated, and there is information and advice to ensure the risk associated with this hazard can be minimized, including our recent film about the safe handling of solvents. Thank you for watching this short presentation, and if you need more information, please view our comprehensive websites.